Welcome everybody. This is going to be a bit of an introductory video. Not much is really going to go on. I just wanted to inform you that I would like to actually, I'm going to do some making a game. We're going to do a bit behind making a game with X and A and stuff like that, and I would invite all of you to come and help me. So we have Visual Studio here. We'll open this up. So basically what I'm going to do is that I'm going to be doing a lot of underlining work of making a game, as well as other stuff, little bits of tidbits behind all the engines and stuff like that, as well as the animations and stuff as well. So what I'm going to do is I'm going to start out slow, doing stuff that's not really heavy, and then I'm going to go further up into creating actual images, characters, sounds, stuff like that. And once I get to a point, I would like to invite anybody, if this catches on, to help out by giving me any assets. You guys can send in music, sound effects, characters, sprites, stuff like that. So you guys are going to help me make it. So I'm going to do all the coding, stuff like that, as much as I can, or people can actually help me with coding if they really want. And then people will send in their images. I will give more details on the images as the time goes on. Woo, look at this go. Woo. Sorry. I get distracted easily. So yeah, I'm going to invite you guys to help me out. So what we're going to do here is we're going to start. We're going to make a new project. Now this project is not going to actually be a game. It's just going to be a simple console application. We'll call it console application 1 here. Nothing special about it. So here we have our Solution Explorer. This is where all our files will be handled. You'll see stuff like content, and it will be slightly different once we get into the game. But for now, there's not much here. So let's bring this down. We don't need that just yet. So here we have our basic startup program. Here's the main. This is where everything is going to start from this point and go from one instruction to the another. When you hear stuff like gigahertz of processing power and stuff like that, what it's actually talking about is the number of lines executed per second, and a line executed is anything that ends in a semicolon. So imagine 6,000 of these, I think a hertz is, I forget. But that's a lot to be executed in a second, which you would have to understand a game really needs. So we're going to start out. If people want more of a basic understanding of actual programming, I might be willing to do that if I get enough requests for it. But I'm going to start out. I'm not really explaining too much. I'll just explain as I go. So first thing we're going to do, we're going to right-click here on the Solution Explorer console application solution. This is the actual project file itself. We're going to right-click, go to Add, New Item, and we'll just make a class for now. It's not like it really makes much of a difference at this point. We're going to call this class Point, and there we go. And it's not really a class. We're going to actually call it a strut. There's not too much difference between a class and a strut. A class is just more detailed, more functionality to it. A struct is slightly faster, as most of the time people use structs to allow public access. I'll get to that later. Now before strut, you always have to declare one of the accessor types. By default, I think it's always internal, which means it's only referenced within any of the namespaces here. So anything with the namespace console application 1 will be able to see that if you have the, not interface, but internal, there we go, keyword in front of it. Anything with the console application namespace will see this. Anything outside will not. But we don't want that. We want it to public. I don't think you can have a private. No. Anyways, this is the access modifier. This determines who can see it. And it's, for now, everybody can see it, no matter where they are. Inside, it's just inside this solution project, whatever you want to call it. So what we're going to have is this point is actually going to represent somewhere on the screen here. Each point is, I believe it's a pixel. So I have the pixel the different points will be at. Or I'm not sure if pixel, I think it's maybe a given size or percent or something. Anyways, what this is going to do is we're going to turn the x, this is going to determine the x and the y point of where an object is. So my mouse is currently, say, roughly in the center of the screen right now. And that's going to have the point structure, which is going to hold the values of x and y. So we'll make them public, so anyone can access them and modify them. And we're going to make them float, and we're going to call it just x for the x coordinate. Public float y for the y coordinate. So that will hold our data of an x and y coordinate, of where any object is that's going to be displayed to the screen. Also, we're going to create a constructor. What a constructor does is it predetermines how the object is built. All objects in C# they have default constructors which pretty much populate this stuff to, like, you can do it this way. Oops, not that way. 0.0. Sorry, it's really dark in here. F. You can do it that way, or we can do it with a constructor. Constructors first have access modifiers, so public, protected, or private, which I will get into those further. For now, it's just going to be public. And they're always named after the class, or strut in this case. Point. Get my point? So, then we have the brackets, which will hold the data. Float little x, float little y. Now variables are case sensitive, so these are going to be two different variables. Why are you complaining? Oh, okay. So we're going to make x equal little x and y equal little y. So what's going to do is you're going to pass in two floats, an x and a y, and it's going to assign the values to any instance of this object to the values you passed in. So that's all good, so let us go back to our program and we will create a point. So we call the data type, which is the name of the class, or strut in this case, we'll call it little point. There we go, little point. Now it's going to complain, point being declared, I never use it, right? Now there's two different points. There's this way to do it, which I don't believe, yeah, there's this way to do it, but you have to populate it by doing this. You have to literally call them by using the accessor, which is the period after the variable. So here's the strut point, and this is the variable. You're going to see a lot of this. There's going to be a lot of periods everywhere. So it's going to be period, and we're going to take the x, and we're going to say it equals, say, 5.5f. And we're going to take the point dot y. It's really awkward typing like this. It's kind of like it's just slightly off. 7.6f. Now we have to say the f because the compiler is not smart enough to be able to tell the difference between a float and a double. A double is twice the size of a float. So we have to put the f to signify that it's a float. Now this is how you declare this. And we'll display to the screen. How do we display to the screen? I'm going to call console dot write line. You can do write, or you can do write line, which will create a new line after it displays everything, but we'll do this. Point.x plus, which means we now have a string. A string is like, it's a string. I don't know how else to say it. It's like a sentence. it's going to convert this float here, which is the float inside the point structure, to a string. It's going to append a blank space after it. Then it's going to append the y. Awesome, eh? Then we don't want it to like disappear completely, so we're going to console out and read key. This will briefly stop and wait for us to press something. So let's run this. See, there we go. 5 and 7.6. Cool, eh? Now, one problem with this is it only has variable inside scope, meaning anywhere if you put the brackets in. There we go. Notice it's giving us a compile error. That's because it's created on the stack. Now, the stack and the heap are two different things. The stack, as soon as it reaches out of the scope, everything in the stack that was created in between here is removed from the stack. So this point no longer exists at this point in the program. So that's why it's complaining. We haven't actually declared it. Now that's going to come more into effect later. Now how do you want to avoid that? Is you want to use the keyword. There's an easier way to do this. How you want to do that is you want to use the keyword. Like, you still wouldn't be able to do it this way if you want it, but I'm just saying as soon as it goes outside those two brackets, this object will be deleted. So if you tried to say you saved it to a variable somewhere else, the variable would now point to nothing because it didn't save it properly because you deleted it out, and that causes issues. That takes a lot of explaining to do, and I will probably explain it at some other point. But what we want to do is delete all this crap space. We're going to use the keyword new. This will create it on the heap, allowing it to remain in memory until we are done with it. So we're going to say new point. Now remember, we had the constructor. We have the default one, which will populate our x and y with zeros. Or if we press down on the keys, we have our float one. So we'll say this point 0.5, f again, little diddly do, I forget what those are called. We'll say 8.6f, so it makes it slightly different. And there we go. And now we'll run it. There we go. There's our two different points. This is usually the way you want to do it if you want to keep information. If you're using temporary stuff, you'd probably want to do it the other way. Both ways are acceptable, really, but doing it on the stack makes it quicker, a little quicker, and a little cleaner. Less garbage collection for the compilers, not slowing it down as much. So, there we have our point. Now we're going to make, say, another point. We're going to do an array of points. So we're going to say the type, and it's going to be a type of array. That's what the little square boxes mean. We're going to call it points with an S. We're going to say it equals new point array, and we'll say array of 5. Boom. So now this will hold, this thing here, instead of holding one point object like this does, it will now hold 5, or whatever number you determine. We'll create a little for loop. A for loop will actually loop. There's different kinds of loops. There's a while loop, which will execute as long as a condition is true. Do while loop, which will execute at least once while a condition is true. And a for loop, which is the most common and easiest one to use for arrays. All loops have their places, but usually for loops are more prominent when it comes to dealing with arrays. So for, you can use a while loop as well, but for loop works well. So we type in the keyword for, and then we'll open close our brackets here so we don't forget. So first we need an iterator. An iterator is going to have to be an int, which is an integer. So a 1, no decimal spots whatsoever, and it's a number. We're going to call it I, and we're going to set it to equals 0. I'm going to put some, not indentation, we're going to put a semicolon at the end, and then we're going to have our condition statement. We want this to loop through as long as I is less than the size of points. So points dot length. So this will actually loop through the entire array of points and stopping at the end. Now you don't want to go while it's equal to, because this causes an index out of bounds. Even though we assigned it 5, the actual values are 0 to 4, not 1 to 5. Remember that. It starts at 0 and goes to 1 less than what you assign it. And the final step in the iteration is to do the increment. It can be plus plus, so increments from 1, 2, 3, 4. We're going to say plus equals 2, 32, whatever you want, so it'll increase. You can make the iteration whatever you want. Most common is usually this. Let's do open close brackets. So we're going to take our points, and we are going to get each index of I, so this will get each point object in the array, starting at 0, going all the way up to 4. We're going to assign x value to equal I points I dot y going to equal I multiplied, which is the 2, or multiplied, which is the star, by 2. So that's going to populate our array. Next, what we're going to do is we're going to copy this. You should really write this out, but I'm trying to save a bit of time here. We're going to copy this out, and we're going to display our points. And this also should have a semicolon at the end. My apologies there. I shall be making quite a few mistakes probably. There's going to be quite a few mistakes, and I'm going to run into stuff, because that's kind of what happens. So points is an array, so we have to access it by using the square brackets. And yet again, we're going to go through each index. You can hard code the values, but it would continually display the same number. So that's going to display each one. So let's see what happens when we run here. There we go. So 0 times 2 is 0, 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6, 4 times 2 is 8. Cool, eh? So what this means is these points are going to determine a position on the screen here, starting right here in the top left corner, not counting the bar, to all the way down here. Actually, it can go outside the bar, but 0, 0.00 starts right in here, right there. You can't really see it, but it starts right there. So that means 0, 0 is right there, 1, 2 is right about there, 2, 4, 3, 6, and 4, 8. Just like that. Cool, eh? So that's going to determine where our characters and objects are in the screen eventually, but this is the most basic thing of what every game starts off with. So, hopefully you've enjoyed the episode. This is about it. Like I said, follow along. Let me know what you want. Right now I have no serious plans for a certain kind of game, but chances are it's not going to be a platformer, because a platformer requires a lot of physics, and I hate physics. So I'm thinking 2D, top-down, Zelda-esque, or RPG, I'm hoping, or anything that doesn't require physics. So, like I said, follow along. Let me know what you think, and hopefully, if you really want to get into this, you guys will be sending me your assets and stuff like that, and I'll get your name into this, and we'll hopefully develop a nice game together. I don't know how far this is going to go, but I would like to get a decent, doesn't have to be a perfect looking game, but I would like to get a nice game that everybody can be proud of and all of you be part of. Thank you for watching, and have a good day. Bye now.